First off, we will talk about the cuvette. This holds our stock solution and its dilutions that will be used in the spectrophotometer. The line right under the arrow is the line that we will be filling up the solutions to. Before we use the spectrophotometer, we need to know what the data represents. To access the data we want, we will have to first scan through all wavelengths with our instrument. Scanning through all wavelengths allows us to create a visual spectral scan graph where we can point out our lambda max. The lambda max can be observed as the highest peak on our spectral scan. This peak represents the wavelength at which our substance has the strongest photon absorption. After making sure that we clean the sides that light will be passing through on the cuvette, we are now ready to insert our blank cuvette, which in this case will be holding water to zero the spectrophotometer. Closing the door to the spectrophotometer, we now see that we are going to get a reading that is close to zero. This means that we can move on with the procedure. Beer-Lambert's law defines a linear relationship between absorption and concentration. The linear relationship is set into the equation A equals ECl, where A represents absorption, E represents molar absorption coefficient, C represents molar concentration, and L represents optical path length. The molar absorption coefficient can be determined by looking at the slope of a concentration absorption graph. Molar concentration can be determined by dividing moles by liters of water used in the solution. Optical path length can be seen as the product of the thickness of the solution and the differences of refractive indexes. Now, the importance of zeroing the instrument. You only care about the light lost by absorption of your sample, so you run a blank cuvette in the machine first, and the machine will save the absolute light value in its computer. Then, when you put the sample in, the computer will automatically account for the light that was lost to all of the things that wasn't in your sample. Looking at the video here, we have set the stock solution into the spectrophotometer, and now we get the reading 0.8413 for our stock solution, and we will write that down in our notebook. After completing the procedure, make sure to clean your workspace and also make sure to clean your lab space in the other room.